Hello everyone, it's Mrs. C. I'm here with you with some extra practice on simplifying expressions. There have been many of you that have moved on, but yet there's many of you still hanging back, still trying to get a handle on the simplifying expression problems and trying to get mastery so you can move on to the next. So I thought it would be a good idea to rewind it all the way back to some of the basic simplifying expressions and then slowly move you into the ones you've been working on. Maybe you just need to look back at the basics and then maybe travel a little slower through the journey. So let's take a look at this problem number 7. I didn't show you 1 through 6 because they were all pretty much like number 7. And so we'll start right here following the rules that I know you already know. When you combine terms, they must be exactly alike. So in the case of number 7, let me see if I can make this a little bit bigger. Sure I can. In the case of number 7, we have an R term and another R term. So we have 2 R terms, and we have to ask ourselves, can I combine them? Are the R's exactly alike terms or the same term? Now don't look at the 11 or the 12. That has nothing to do with whether the same term. You're looking at that back, that variable, and they're both R's. So yes, they are exactly alike terms. We can combine them using the rules of addition. And here's where you have to remember, if it's the same sign, meaning this sign, which is a positive, and this sign, which is a negative, if they are the same sign, you find the sum. Same sign, sum. If they are different signs, you find the difference. Different, difference. Now, sum, as you learned a long time ago, means to add, and difference is when you subtract. So what would we do? Add or subtract the 11 and 12? Well, they're different signs. Different signs find the difference. Well, when you take 11 and 12 and subtract them, the smaller from the bigger, you would get a 1. The question then is, what is the sign of the number 1? Is it a positive or is it a negative? Well, you take the sign of the higher number. So who is bigger, 11 or 12? Well, that's a silly question, right? You know 12 is bigger than 11. And if you see the sign of the 12 is negative, that means this 1 is going to be a negative. So it's same sign, sum, keep the sign. Different sign, find the difference, sign of the higher number. And always put the R. Now you're going to see the answer key is going to actually write this as a negative R. They don't write the 1 because that's implied if there is no other number in front of the R. Okay, let's try another one. Now, here's the beauty. All of those rules we just went over, they apply to every single one of these problems. So if you see this next one, can I combine them? Are they exactly alike terms? Yes, they are. They're both V's. So I just have to decide, are they same sign or different sign? Here's a negative. Here's a positive. They're different signs again. Different sign, find the difference. So I'm going to subtract them. But this one kind of throws you a little bit because you can't quite figure out what number you're supposed to subtract because there's no number there. Well, the same reason, if you don't mind me bringing you back here, you see here? Negative R is the same as a negative 1R. They're the same. So then negative V is the same as what? Negative 1V. So this would be negative 1V plus 12V. Different sign, find the difference. That means we subtract a 1 and a 12, we get 11. Sign of the higher number, 12. So it would be positive, and don't forget your V's. Do you have to put the positive in front of the 11? Absolutely not. You do have to put a negative, though. Okay, here we go again. We have a negative 8x and a negative 11x. They're both x's, so they are combinable. So the question is, same sign, sum, different sign, difference. Well, they're both negatives. They're the same sign. Same sign, sum. That means you add an 8 and an 8. An 8 and an 11 would give us 19. Don't forget the x. Don't forget the sign. Same sign, sum. Keep the sign. Negative. Now, I'm going to tell you something. It's always kind of bothered me because I know it confuses you. The same sign, sum, you keep the sign. different, sign of the higher number. It seems like they're different rules. If it makes you feel better, just always take the sign of the larger number. It's never going to steer you wrong, because in this case, the rule is same sign, sum, keep the sign. And the reason we say keep the sign is the signs are the same, you just keep them. But technically, if you always just keep the sign of the higher number, no matter what rule you follow, you're always going to have the right sign. You may not quite have the understanding of why, but at least your answer will always be right, and maybe the why will come later. And you can think back, why is it the sign of the higher number? Well, it's because when I subtract, I take the sign of the higher number because that's the number that I have left over. They're all that sign. Same sign, I'm combining all the same sign, and I'm adding them so they're all that sign. You know what? That understanding can come later. If you're confused by what sign, just always take the sign of the higher number no matter what rule you follow, and you'll still get the right answer. All right, well, let's move on to a little bit saucier problem. Let's take a look at number 12 down here. The reason 12 is a little saucier is because it has more than two terms. Here we have an in, and over here is an in. And then let me do a quick color change. Here we have a constant and a constant. And so what we're looking for is a combination of the constants and the number term. And the variable term. So let's do our ins first, okay? In, that would be a 1 in and a 5 in. So a 1 in is a positive. You see there's no sign in front of it. That's implied it's positive. And the 5 in is a negative. Different sign, find the difference. That would be 1 and 5. The difference is 4. Keep the in. Take the sign of the higher number. That would be a negative. It would be a negative 4 in. Now let's go to the greens. Those are our constants. We're going to combine a positive 4 and a negative 9. Different sign, find the difference. That would be a 4 and a 9. Subtract would give us 5. Sign of the higher number. That would be a negative. So your final answer, not all in all these different colors, would be a negative 4n minus 5. Easy breezy. Box your answer. All right, shall we try another one? I think we shall. Let us try. Let us just go right down. Oh, ran out of screen there, didn't I? Let's try this one. Now, if I go with what I know, I combine the terms that are the same. So I have a negative 5 matches the positive 6 because they're constants. There is no other in to combine 9 in with. That's awesome. Less for me to do. So I follow the rules, difference, sign, difference on my reds here. These are my constants. I'm going to find the difference. That means subtract a 6 and a 5. I get a 1. Sign of the higher number, I get a positive 1. I just bring the 9 in down because there's nobody else to combine with. There it is. Let's look over here, see if we have anything better. Oh, I'm liking number 13. Lucky number 13. I have a 12R and a 3R, a positive 5, and a negative 5. So let's do the unders. Let's do the 12R and the 3R. Same sign, sum, keep the sign, or same sign, sum, sign of the higher number. It'll be the same. Sum means you add. 12 and 3 is 15. Mrs. Crusoe, why'd you say they're the same sign? I can't see a sign on number 12. If it has no sign, it's assumed to be positive. That was an excellent question. Thank you. No problem. Remember to write the R. So a 12R and a 3R is 15R. And even if you want to do this to show that you kind of already put them together, we're not canceling them out, but it helps you to not accidentally add them to another number. Then we have the positive 5 and a negative 5. Different sign, find the difference. Well, 5 from 5 is 0, and 0 has no sign, so we don't even have to worry about a sign because you notice nobody's bigger. I can't take the bigger sign. So that's out. 0. Now, do you want to write 0? No, I don't want to write 0. Why would I do that? It's just 15R. Okay, let's try another page. Hopefully you're getting the hang of it. You're going to notice this sauces it up just a tiny bit. Now I want you, as I take a sip of my coffee, because it's the morning, I want you to take a look and see what's different. Nothing like a nice cup of coffee on a Sunday morning. What's different? There are parentheses. Good job. Now the parenthesis adds a little bit extra. Fear not, my younglings. We will just take it one step at a time. Hopefully, by the time you come to me, you have done the distributive property. If not, fear not. We'll just take it right now. Take a look at the distributive property. So look at number 21, and let me get rid of all that extra stuff. You're like, whoa, you can't do that. Sure I can. I am in control here. Now, the distributive property states that if you have multiplication, you do that before you do anything else. And that's not what the distributive property states. That's the order of operations. The distributive property states that if you multiply that outside number to both of the inside numbers, you will not have done anything different than you would if you had done the inside stuff first and then times it to the outside. Now, first of all, I don't like the color. That's number one. Number two, it's too thick. And number three, I'm not sure you understood what I just said, so I want to try it again. Okay. The distributive property states that 7 times 1 and then 7 times negative 3n gives you the same as if you combined these using the rules of addition or subtraction and then times them to that. Let me prove to you that is true. 2 times 1 plus 4. The distributive you're like, where's that problem? I made it up. I want to prove a point. 2 times 1 is 2. 2 times 4 is 8, and it's a positive 8. The distributive property states you will get the same answer if you add those two products, so 10. Then you'll get the exact same product as if you just went ahead and added these first. 1 plus 4 is 5, and then times them to that number, which would be what? 10. See? It works. That's the distributive property. It's just another way to get the same answer. You're probably saying, but one way is fine for me. I liked the old way. You add inside the parentheses, then you times. Okay, but don't we have a little problem here? We can't combine a 1 and a 3m because they're not like terms. So no, we can't use the old way. We need to use the distributive property. The old way doesn't work with variables because I can't combine the insides like I normally would have. So we use the distributive property. No big deal. 7 times 1, my pen stopped working. 7 times 1 is 7. 7 times a negative 3m. Okay, you got to go to sidestep to multiplication and division rules. Positive times a negative is negative. Negative times a negative is positive. Those are rules you learned a year before. Positive times a negative, always negative. Negative times a negative, always positive. So in this case, positive times a negative, always negative. 7 times 3, 21. And the m, if there's an m, you keep the m. So we have the final answer. You're like, that's it? Well, that's it for this part. I happened to cover something in green a minute ago. We're going to bring that back. But that's it for this problem. If this had been the only problem they gave you, then you're done. You'd box this answer. But I do believe, there was a negative 4 we had to combine. Now, I don't want it to be negative 47. What was the sign of the 7 times 1? It was a positive, right? Okay. Combine like terms. Who can we combine the negative 4 with? That's correct. Negative 4 and positive 7 are like terms, so we can combine them now using the rules of addition. That was the ones we did on the previous page. Different sign, bind the different sign of the higher number. 4 from 7 is 3. 7's bigger than 4, so it's positive. That's taken care of. Bring the negative 21m down, and you're done. Let's do it again. Come over here. Let's say we do this. Look at that. Okay. And I'm doing that so that, I didn't mean to do that. I'm doing that so that we focus on one thing at a time. You can cover it with your finger. You don't have to, please don't take a pen and mark it off. You won't be able to erase like I can. Cannot combine a 6 and a positive 7 in. They're not like terms. So I will use the distributive property. 3 times 6 is 18. 3 times 7 in. Positive 21 again in. Let's erase and see what mystery is unfolding here. Remember that this 18, the 3 times the 6 was a positive 18. Bring down the negative 5 in. I want that positive in front of the 18, so I don't think that they're together. Who's alike in this case? Your variable terms are alike. They have different signs. One's a negative, one's a positive. Different signs, find the difference. Sign of the higher number. 21's bigger than 5, so my answer is going to be positive. 5 from 21 is going to give me, what's it going to give me? 16. I just double check that in my head. I don't want to screw it up. 16 in. The n comes along for the ride. Plus 18. Final answer. Nice. Okay, let's try another one. Let's come over here. Color switch. Okay. Again, you can continue to do something that's like I'm doing here so that you focus only on what the task is first. You have to do the first things first. Now, this time we have a negative. Negative? You're saying negative. Negative what? Okay, well, let me help you here for a minute. Let me get rid of all this nonsense up here. Let me get rid of that for a minute. There's too much going on. Let me do a little bit better of a job there. Okay. So the question is, a little confusion. I'm changing colors so that I can make it very clear. Here it is. When you go to distribute, some of you get confused with where's the number. Totally understandable. We don't show this. This is a 1. Negative 1 times the quantity of 9 minus 10 in. That's what that means. We don't show the 1 because we don't feel like we have to. The fact that we don't show it sometimes confuses new students. So if you want to just squeeze a little 1, you see how I did that with my blue? I just squeezed the 1 in there. Feel free to do that because watch what happens. Negative 1 times 9. Negative 1 times positive 9 is always negative. Negative times positive is negative 9. Negative times a negative 1 times a negative 10. Negative times negative is positive. 1 times 10 is 10. N comes along for the ride. That's what we have right there. Now if we erase so that we can see what we had in the front, we had a negative 2n. There was already a negative here, so that was awesome. I didn't have to write a sign. Combine like terms. Excuse me. Different sign. Find the difference. Sign of the higher number, so I have a positive 8n. Bring down the negative 9 because there's no other constant term. Okay, let's try another one. Let's come over here. I'm going to erase the top so that it doesn't interfere with my drawings here. Negative 5. Here's your distributive. Now notice I'm not blacking it out anymore because you do have to kind of deal with it. If it bothers you, put your finger over the 10. Just don't put your finger over the sign in front of the 5 or you're not going to know it's negative. Negative 5 times 9n is a negative 45n. Negative 5 times negative 9 is a positive 45. Bring down the 10. Combine like terms. 10 and 45 is 55 minus 45n. Final answer. Let's try another one. Let's do this bottom one right here. Erase the stuff there so it doesn't confuse you. 10 times 6a, 10 times negative 1. 10 times 6a is 60a. 10 times negative 1 is negative 10. Bring down the 9a. Put the positive in front of the 60. Combine like terms. That would be the a's in this case. 9a and 60a. I'm going to come over to the right. 69a. Same sign sum. Minus 10. Alright, let's go to another page. This next page I have some of the ones we just did, but down towards the bottom they were a little saucier. These are no different. In fact, I kind of feel these are almost a little bit easier than those because they're a little bit more predictable, I think. If we come here, I'm going to make this one a little bit bigger. It's like having two problems, guys. I'll use the blacking out for a minute just to show you. The first problem has, well, that's not good. The first problem has you do that. So let's do it. We do the negative 9 times the 6, negative 54, right, m, and then negative 9 times negative 3, positive 27, and then it has you continuing. And so you switch to the other one, pretending that's not there right now, even though you already did it. And so now what we do is the 6 times 1, positive 6, 6 times 4m, positive 24m. And what happens is, in the end, you've done this whole thing. And this big long thing that you have is the result of doing the distributive property to both. They just sit next to each other. See, it's not that big of a deal. Now, when we come to combine, we're just combining like terms. Here's a 54m, here's a 24m. We combine those together. And over here, here's a 27 constant and a 6 constant. We combine those together, and then we're done. We have a little, what's called a binomial, a two-term expression. So let's combine the m's. We have a negative being the bigger number. 54 is bigger than 24. So I'm going to put the negative down first before I go try and figure out what's 24 from 54. Well, 24 from 54 is 30, and it's an m. Okay, so that was pretty straightforward. And then when we combine the 27 and the 6, they're the same sign instead of different. So I'm going to actually add them together and get 32. No, 33, excuse me, I did that. 6 and 7 is 13, not 12. And there's our final answer. Right there. So you see how they're really no different. They're a little longer, that's all. So let's go right below it is number 28. And let's try that without doing the blacking out part. All right, so it's the 5 times the negative 20. It's the 5 times the negative 2. That's a negative 10n. It's the 5 times the 4. That's a positive 20. And just keep going. It's a 2 times the n. That's positive 2n. It's a 2 times a 3. It's positive 6. See, that's a lot easier than doing the blacking out. You can always cover with your finger, but don't cover the sign in front. That one is fine. Well, the positive wouldn't matter, but what if that had been minus 2 times the quantity? Don't cover the sign. It's got a times in. Let's combine these guys first because they're in front of me. It doesn't matter who you combine first. No, it doesn't matter for now who goes in the front, whether it's the variable term or whether it's the constant. So we have a negative 10 and a positive 2. That's a negative 8n. Different sign. Find the difference. Sign of the higher number. And then I have a 20 and a 6. There it's 26. Negative 8n plus 26. Again, I'm only putting lines through those, not because I'm canceling out like we do when we do the opposite operation. It's just I want to make sure I don't, accidentally add the 6 and the 10 together because I've already done it. And they're not like terms. So just a little trick I use to keep from screwing up too many times. Okay. I think it's a long video. I try to keep it a little bit shorter than what's almost 25 minutes. But I know that you needed it. I think you really needed somebody to go over step by step what was going on. I want to remind you that this worksheet came off of CUDA software. Okay. I know we haven't used it that much. It's the beginning of the year. CUDAsoftware.com. If you go to CUDAsoftware.com and you go to the Algebra 1 free worksheets, which is off to the left tab, and you click on what this was called, what did I tell you? Do you remember? While you're trying to remember, I'm trying to remember. I think it was called combining like terms. Yeah, I think it was combining like terms. And when you go there, this is what you're going to find. You're going to find all of these answers because remember, CUDA, I've told you in class before, CUDA gives you the worksheet, and then at the bottom of the worksheet, it gives you an answer key. So you can do any of these problems, 1 through 30, and then look at the answer key, there's still plenty of them that I didn't do. So, best for you to practice as much as you possibly can, but always with answer keys. And just so that there can be no reason that you don't actually do what I just suggested, I just paused the video and took a screenshot of where you should go for your practice. So here it is, guys. Here's the URL. You can't hide from it. It's right up here. It shows you exactly what to type in. So you type in www.kudasoftware.com, and then you'll see this right here. And you want to come all the way over here. I'm going to make my pen a little bit bigger. Come all the way over here. Here's your Algebra 1. And you notice I'm already on the Algebra 1 worksheets, but if they don't give you this page, you want to select the free worksheets, which are right there, free worksheets. And it brings you to this page, Basic, and you're going to see Combining Like Terms. So when you click on all of this, click on the Combining Like Terms. It's going to take you to the worksheet you just saw me do. I did not do all of them. There's like 30 of them. I definitely didn't do 30 problems. And then at the bottom, there are all the answers for you to verify. And even better, could you please verify all my answers? Make sure I didn't screw anything up, because this is going to YouTube and I want to make a correction if I did anything wrong. Maybe I need another cup of coffee. Take a look as you go down here. You're going to, not going to let me go. That was how big I made the screenshot. You see all of the different practice. There's tons of page. There's much more of the page not showing, where you can get all kinds of practice on everything we're going to do this year. So there's plenty of work there for you guys. You just got to go out and get it. I hope this helped. Sorry it went a little bit over, but I think it was well needed. And just use your fast forward on me, when I start to bore you. Anyway, guys, bring your questions to me immediately. As soon as you see me, say, "What's up with that? I didn't understand." I'll help you out. Guys, this is Mrs. C, signing out. I'll see you on the flip side.